Alrighty, here we go. We're back for part 3, so that we can get this done real fast. We're going to here on part C, so this should be the third number 29 slide. Alright, and so we're doing across the line y equals 2. Y equals 2 is this line right here. And as a refresher, this is y is equal to square root of x. And so I'm going to be taking this black area and it's revolving around y equals 2. So there's my little arrow. I'm going to draw my reflection of it. So I'm going to go up about that much. And there. There's my graph. Alright, so now what I want to do is I want to be able to find out, okay, what's my radius? Okay, so the best thing I could say is that when I'm doing my circle here, I have to figure out what my radius is. What's my radius? Well, the center of my circle is always what I'm rotating around. That's why I always put my dot here. And I want to find out, I go down to my original function. I need, that right there is my radius that I'm looking for. How can I find that radius? Because it's not a part of any function that I have. It's a leftover piece of a function. So sometimes it may help you to draw a second one. What happens if I draw this one over here? And now here's this one and this radius. Sometimes, like I said, it helps to draw two circles. Maybe you can try and see what's happening. And so what I'm seeing is that this radius can be described as this whole distance minus the blue distance. Again, this whole distance minus the blue distance. Well, what's this whole distance? Each time, no matter what it is, the whole distance is always 2. So my radius starts off as being always 2. And then I'm going to subtract the blue distance. Well, what's the blue distance? That's my function height. So I'm going to subtract the square root of x. And that's going to be my radius. And now I'm set up to try and figure this out of doing my integral. Again, since I'm revolving around a line that is parallel to the x-axis, everything's going to be in terms of x. So again, this is going to be from 0 to 4. And pi radius squared 2 minus square root of x squared dx. And you'd be like, whoa. Okay, so we're going to quickly go ahead and not factor, but FOIL this out. Pi 0 to 4 minus 2 square roots of x plus x dx. I'm now ready to take my antiderivative. So that'll be 4x minus, this here would be 2x to the 3 halves divided by 3 halves, which is the same thing as being multiplied by 2/3, plus x squared over 2, evaluated from 0 to 4. I go ahead and I plug in, and I plug in the 4, and I get 16. That's 2, that's 8. 16, 32 over 3 plus 16 over 2, 8. And I then plug in the 0, and I get 0 minus 0 plus a 0, which is 0. and all of that multiplied by pi. And I do some quick math, and I find out this is 40 thirds, that's pi, units cubed. Whew. That was fun. Okay, so again, you gotta be mindful of where where your radius is at. Okay, last one that I'm gonna do a detailed example on, 29, part D. I now want to revolve this around the line x equals 4. It's not on there, so here it comes. X equals 4. I'm going to revolve it around there. And when I revolve it, I'm going to do my there we go. There's my reflection. And I have to, it's not so good, but it's good enough. I have to make the decision of, again, what am I going to use? Am I going to use rings? Okay, so it can be a ring, okay, or a washer, excuse me, or a disc, circle. And that's where I say, well, is my area completely flush against what I'm rotating against? No, there's a space. So when I go ahead and I draw in my center of rotation, I draw in, hey, this is all being rotated all the way around, dash, 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 dash. That's better. Get a little eraser here, little eraser. Can't be perfect all the time. And then I got to get my ring part comes here. Okay, and there's kind of my ring that's sitting inside there. And I got two different radiuses that I've got to try and find. Okay. Two different radiuses. I need to find my big R and my little r. So again, because of this, it's going to be integral of pi big R squared minus little r squared. And because I'm rotating around something that's parallel to the y-axis, it's going to be in terms of dy. So what's big R? Big R goes from the center of my circle, which has the center of rotation, to the outside ring that goes all the way out here. All the way out here. And if I choose a different radius, no matter where I choose a radius, my big R stays exactly the same. It doesn't move. It's always going to be that distance. What is that distance? 4. So big R is going to always be 4. Well, what's little r going to be? Little r is this distance from here to here. And that does change as I keep going up and up and up. But again, it's not my function value that it's there. No, it's not the x part, it's a piece of it. Specifically, again, this little r is the 4 that was here minus the green. And that green is my function value. Oh, wow, yeah, that's right. That's from our previous, like when we first did our first one, okay? Our second one, excuse me, when we went around the y-axis. This was my function value. So I'm going to take to get this little radius, this orange piece here, I need to take the whole 4 and subtract out the green piece each and every time. So little r is going to be the 4 minus the function value. Well, this again was y is equal to the square root of x, but I want it in terms of y. So in other words, it's going to be y squared. All right, so then I go ahead and I plug things in. I get pi integral of 4 squared, which is 16, minus 4 minus y squared, dy. And because it's with a function value of y, I'm going from 0 to 2. Again, now I have to FOIL. So you get pi is the integral of 0 to 2 of 16 minus. Now when I FOIL and I have this minus sign, I'm going to keep that parentheses there so I can keep track of where my negative is. And this will be 16 minus an 8y squared plus a y to the 4th dy. Some things are nice and cancel out for me. I have pi, the integral from 0 to 2. The minus 16 goes away, but I'll have a positive 8y squared and a negative y to the 4th dy. And now I do my antiderivative. Pi is now going to be times 8y cubed to the over 3 minus y to the 5th over 5 from 0 to 2, which is equal to 64 thirds minus a 32 fifths times pi, and I plug in the zeros, and I still get 0. And then after some quick math, I get 224 over 15 pi units cubed. Okay. The hard part on these is deciding where the radius is. What is it a ring or is it a disc? Okay, where are my two radiuses? Some will be easy, some will be difficult. All right, so here's what the plan is for these next 5 examples. Okay, I'm going to tell you which one we're on. I'm going to tell you to go to it and to pause me. And then when you get done, unpause me or hit continue, and you will be see the answers. And then we'll go to the next one. It should go very rapid succession from here on out, except, you know, if you feel like you know what you're doing, then do it. Then skip me. If you don't feel like you know what you're doing, see if you're getting the right answers. All right? Good luck. Enjoy. So this first one that we're going to do, is number 30, part A. And there you go. And to help you out here, this is y equals 2x. And this is x equals 1. And you'll see on the flip side. Boom, here's your answer. Okay. One of the main things that I'm going to tell you about this is that, hey, if we're revolving around an axis that is not the x or the y axis, you need to be thinking about, well, it's going to be that my radius is going to be something minus something. All right? And that's a hint for the next one for part B. It's going to be something minus something. In this case, we have a disk. There's the work. Questions come later. All right, so next one, we're going to go over here and we're going to do 30, part B. This time we're going to revolve it around the line x equals 2. So just for those of you that need the extra help, here is x equals 2. All right, so what we have going on here is, again, it's a ring. My big radius, okay, was always going to, my big radius, that's what's changing, and it's going to be 2 minus my function value, minus the little function value, so 2 minus the little function value gets me the whole big radius, and my little radius is always this distance here, which is 1. Okay, and boom, that's all the setup. Time to go. Next one is 31. So here we find a parabola. There's my equation, y is equal to x squared. We're going to do part A along the line y equals 1. Here's my line, y equals 1. All right, go. Boom, there you go. So this time through it's going to be, because the entire shaded area is a flush or up against the axis of rotation, I am dealing with a disc or a circle as my cross section, and so here is my radius. But again, I come across that radius again when I'm not revolving around the x or y axis. I got to do something different to find my radius, and it's going to be something subtracted by my function. Okay, so in this case, that's why my radius is 1 minus x squared, because my radius is always the 1 minus the x squared piece, that little piece that's down here. Okay, after doing that, the rest of it is just plug and chug and get all the way through. Next, we're going to do part B. So this time we're going to rotate around the line y equals 2. So the y equals 2, that's up here. Here's my line y equals 2. And we'll see you on the flip side. Ready, pause. Okay, so again on this rotation, here's my graph of the rotation, because again my center of rotation is not flush with my area that I'm rotating. I am going to have rings, so I'm going to have a big R and a little r. Again, big R, since I'm not revolving around the x or y axis, is going to involve some type of trickery with it. So again, it's 2 minus the little function piece, 2 minus the little function piece, and my r, no matter where I go along here, my little r is always 1. Again, I set it up. Okay, notice that this step here, okay, it went from 4 and then I took the antiderivative. I got 3x. How? I subtracted the 1 first. It was poof, magic. All right, and then I went ahead and plugged everything in. Got a final answer of 56 over 15 pi units cubed. All right, next, last one. Here's the example we're going to do letter C along the line y equals -1. Hopefully this last one you get the drift as far as what is happening. Good luck. And here's all the work for this one. On this particular one, what made it difficult was on here my big radius was always 2. No matter where I was at, my big radius will always be 2. What was my little radius this time? This time I wasn't subtracting something. This time this distance is always 1 plus a little bit more, and that little bit more was my function of x squared. Okay? Whew, these are good problems. They make you think, but you got to be able to find, you got to be able to pull these out. If you have any more questions, feel free to holler, which leads us to the homework that you should have already started of all this right here. Okay? You need to be able to pull this off. I'll let you know when the quiz is on this one. You guys take care, and I hope this was just as enjoyable for you as it was for me. Goodbye.